Hello and welcome to Mr. Sanchez Math Class. All right, guys. I know this is really news. I don't know what I just said, but all right, welcome, guys. Cool cats and kittens. For you, those of you who've seen Tiger King, today we'll be going over lesson 25-2 special products of binomials. Now, this is kind of an extension what we went over last week was just multiplying binomials. But today we're going to look at special products. And remember, products is what you receive from multiplication. So they're just special things we receive from multiplying specific type of binomials. All right. Our learning target is still to be able to multiply binomials. However, that's not our main focus. Our main focus is finding the special products of binomials. And we will be proving things very lightly. We're just gonna focus on some things that you guys need to remember. If you guys remember 25-1, you'll be doing really great. Otherwise, it's gonna be a little bit tough, but keep practicing and you'll get better. Math is all about practicing and getting better. So we're just gonna go straight into our first example, which is difference of squares. Okay, so what does that mean? When you have a problem that's called difference of squares, generally speaking, you're going to have something that looks like this. A plus B times A minus B. Doesn't matter what A or B are, this is what they look like. And we know that the difference of a square, this is a very special binomial multiplication. And no matter what A and B are, when you have A plus B times A minus B, we are always going to get A squared minus B squared. All right? That's just a general. This is something you might want to remember. When we're talking about difference of squares, we're talking about binomial multiplication that looks like this. All right. But we're gonna go more into detail because you're like, okay, this is all abstract. This is not really an example that we're gonna see in our book. Please explain, Mr. Sanchez. Well, I will. Now there is a proof. I'm showing you guys how to do this, how this is true, but I will show you guys using a more concrete example. Okay. So the first example we're gonna do is something pretty straightforward. We're gonna have. All right. So usually, just numbers in there. Usually your A term is usually whatever has x, something with x, right? And your b term, your b, let me see, I'm gonna write it something better. Usually just a number. All right, and I said x, but it can be any variable. All right. Um, so what I mean by this is, let me just get this out of the way, so that it's not distracting us. Oops, hold up. Let's see. Let me just get this out of the way, though. Let me just get this out of the way. Yeah, we'll come back to this later. All right. So we're gonna go over some difference of squares. All right. So usually something with a variable, not a big deal. All right. So we're just gonna go straight into our example. And remember, these A's, this A is this A, and that A. And then this B is, and then this B is this B and this B. All right. We're gonna go more into detail right now. All right. So what we want to do is we're gonna get a problem like this. Let's just start simple. We're gonna have x plus 3 times x minus 3. All right. Now you already know how to multiply this using FOIL. And if we did use FOIL, the problem would look something like this. You're going to do x times x, and you're going to do x times negative 3. So plus x times negative 3. And then you're going to repeat the same process. You're going to do plus 3 times x plus 3 times negative 3. And then when you combine like terms, you're going to get x squared minus 3x plus 3x minus 9. Oops, I forgot the x here. And then when you combine these terms here, they're going to go away. Negative 3 plus 3 is 0. So you're going to get x squared minus 9. All right, so this is what happens if you use FOIL, right? Using FOIL. However, If you look at this, if you note here, our A here, our A, if we list down what our A is here, A here is gonna be our X's, right? So A equals X, and here 3 is equal to B. All right. So what is X? What is B squared? Three. That's 3 times 3 squared, which is 3 times 3, which we know is 9. And for X, A squared, that's gonna be X squared, which is just X times X, which is just X squared, right? So I repeated it, right? And then if we did A squared minus B squared, we would get X squared minus 9. All right. So this whole part right here, if you just follow, if when you have something in this form, A plus B times A minus B, you can just go ahead, write your A, write your B, do A squared, B squared, and do A squared minus B squared. All right. That's called the difference of squares. Difference of squares, okay? And you can use flow to check your work, but it's always going to be true. And you can take my word for it, because first, we've been doing a lot of mathematicians have been doing this for a long time. It is just a pattern that we've noticed, which is why we call it a special product. And you only get this when you have x, like a number, something by something here plus something, and then that same something minus that something. Okay, so we're gonna go over one more example before we go sum of squares, and then we're gonna be done. All right. So another example here. Yeah. So let me just move this sum of squares a little bit down, a little bit more down. All right, I think that's enough. All right, so we're gonna be up here. We're gonna do another example. All right, we're gonna have this time we're gonna have something a little bit different. We're gonna have 2x plus 2. No, I don't like that. Let's do 2x plus 3, and then 2x minus 3. Remember, we know it's a different. This is a difference of squares. Difference. There's an e of squares. All right. Difference of squares. And we know it because we're going to have, right here, we have 2x, and we have plus 3 and minus 3. All right. So if we identify our A here is equal to 2x, and our B here is equal to 3. B squared is 9, and A squared is going to be 2x squared. Remember, now this follows the property of exponents, so you're going to have to distribute the exponent to both things. So it's going to be 2 squared and x squared, right? 2 squared, x squared. And we know 2 to the power of 2 is 4, so we're going to have 4x squared, right? So that means that the answer to this problem, 2x plus 3 times 2x minus 3, is equal to 4x squared minus 9. And if you don't believe me, you can go ahead and FOIL it out. I can leave that as an exercise for you guys. You're just gonna have to take my word for it. All right. And we're just gonna move on ahead. We're just gonna move on ahead to go to what is called a sum of squares. Now, sum of squares is something that a lot of people get confused. So pay attention. All right. So a sum of squares usually it looks like this. You're gonna have a plus b squared, which is, or you'll have problems like this. It's going to be a plus b times a plus b. All right, they're the same thing. This is what you call a sum of squares. All right, and this is not how we solve it. What we're saying, this is the same thing. We're just going to try and show this differently. So the answer you should get from squaring a plus b squared, you should end up getting a plus b squared. Quantity a plus b squared is going to equal to a squared plus 2ab plus b squared. All right, it's not this. Never write this. A plus b squared is never a squared plus b squared. That would be wrong. All right, it's never that. Don't write that. If you write that, oh, I'm gonna be so disappointed in you guys, and girls. But we're gonna get this. So ignore that. Get that out of your head. All right. A plus b quantity a plus b squared is a squared plus 2ab plus b squared. Okay. 2ab is 2 times a times b. All right. And then we're gonna do an example for you guys. It's gonna be straightforward. We're not gonna sugarcoat it. We're gonna do it the long way first, and then I'm gonna prove it to you guys that it's the same thing. Okay. And so we're gonna start with just simple numbers. X plus one. No, I don't like one. Let's do x plus 4 times x plus 4. You can get the problem like this, or sometimes they'll give you. All right. Well, let's say they gave you the problem like this, right? X plus 4 squared. Anything is squared is something multiplied by itself, right? So because of the square, we're gonna write x plus 4 times x plus 4. All right. And now we're just gonna FOIL. We're just gonna use the distributive property. You can use the box method. That's fine, so long as you multiply this the long way. So you're gonna have x times x, right? And then you're gonna have x times 4 plus 4 x times 4, and then you're gonna repeat it. You're gonna have 4 times x, right? And then you're gonna do times 4 times 4. All right, and then you're gonna simplify this some more. You're gonna have x squared plus 4x plus 4x plus 16, and then you're gonna combine these like terms, right? And you should get x squared plus 8x plus 16, and this should be the answer. This is what you get from FOIL. You get this from using the distributive property or FOIL, whichever one. It's the same thing. Okay. Now we use the little trick up here, which I want you guys to remember. All right. Let's identify our A. Our A is x, and our B is 4. Right. Oops. This is B. All right. So if A equals x and B equals 4, we need to find our A squared. That's gonna be x squared, and we gotta find B squared. That's 4 times 4, which is the same thing as 16, right? All right, and here we have to find something else. We have to find 2 times A times B. All right, so it's going to be 2 times X times 4, which is the same thing as doing 2 times 4, which is 8, and then times the X, just bring that down. So our 2AB is equal to 8X, all right? Now if you just plug it in back over here, you're going to get the following. You're going to get that this is equal to X squared plus 2AB, which is 8X, plus B squared, which is 16. All right, and so we got x plus 4 squared is equal to this. And I'm running out of time here because our videos can only be so long. This is going to be the exact same thing as this answer right here. All right, guys, stay safe. The assignment's going to be up on Schoology. Hopefully this helps you out. If you need more help with the homework, you know where to contact me. All right, guys, this is Sanchez out. Hopefully this helps. I'm going to have some more videos up later. Have a great week.